Hello everyone, welcome to our part 2 of this Zeno tutorial. It's 3 o'clock in Paris. The day, I would say we can say it's kind of sunny, and no, everything is all right. We are here for another interesting, hopefully, Zeno tutorial. I will wait another couple of minutes to give some time that Lloyd Joyner to join in, get ready to go. And meanwhile, I'll start sharing my screen. So you should be seeing my slides coming up anytime soon. So I will try to leave a little bit more time for questions during this webinar. All the slides from the previous tutorial are in the same deck, and they will be distributed as such. So you will have the entire deck in one file. And I've uploaded already on our GitHub repository. By the way, let me actually copy the link for those of you that missed last week who have didn't have a chance to look at the recording. But let me share with you the repository for the webinar. So this is the repository for the webinar, and you will see that there are already the part 2 examples committed. Okay. So let me go back here and yeah, well, I think this will do. I will put this one on the chat. As usual, if you have questions, type them as they come, and I'll take care of answering them at the very end. So it's 3 minutes past 3 o'clock. I think it's just about time for us to start because we have some material to cover. Okay, so last week we went through the key principle behind Zeno, trying to explain the problem that it solves. We went through the key element of its API in C++ and in Rust. So we looked at how to do a publisher, how to do a subscriber, how to implement a queryable, how to issue a query, both in Rust and C++. We also went through seeing what it takes to serialize user-defined types. So if you recall, we were playing around with images that eventually we were transforming through a queryable in ASCII images. So if you missed it, anyway, there is the recording and the code is available on YouTube, on GitHub. So this week, I want to look at some features that are a little bit less known, and some trying to answer once for all some questions that sometimes people ask, like, hey, how do I actually get the smaller version of Zeno? How do I control the number of threads, and so on and so forth? So without further ado, let's get started with, I would say, the most common mistake when building Zeno. So the right way of building Zeno is this. Okay, so usually people start doing just cargo build or cargo build release if you want release mode. But in theory, if you want to make sure that you want to build all the different elements, then you should really build it this way. Okay, and then the question is, okay, if you run this command, what comes out of the box? Okay. So out of the box will come a certain number of features. So this is the full list of features that are available of Zeno that as of today are considered stable. So you see there are a few of those, and we will see then what are the features that actually are included by default. So authentication by means of public key is a feature. Authentication by means of user and password is a feature. Complete N, we will probably discuss it at the tail of this webinar. So last week we used Queriable in a very constrained manner. This webinar will try to again expand a little bit the horizon of the Queriable, trying to understand not just the mechanics of how you implement a query and you submit a query, but how do you control the target that will receive your query, and how then you control how the data is consolidated back. You have a feature that is shared memory. statistics, which as we will see by default are not enabled, support for multi-link, support for transparent compressions. By the way, few people know that Zeno support transparent compression. I'll show you in a moment how to enable it. Support for various transport like quick, serial, Unix pipe, TCP, TLS, UDP, socket stream, WebSocket, and so on and so forth. So these are the features that are available. And by default, when you build as shown above, this is what you get. So by default, you get a build of Zeno that supports PubKey, that supports user and password authentication, multi-links, compression, quick TCP, TLS, UDP, Unix socket, and WebSocket. Okay, so for instance, if I go back for a moment, it doesn't support Unix pipe. And Unix pipe is something that we use for low latency, which is one of the unstable extension that when used with the feature Unix pipe can be used to get a very, very low latency in Zeno. Okay, so this is what you get, and anything else you have to opt in. And so you could ask, why do I get all this transport with Zeno? Well, because one of the approaches we try to take with Zeno is to make sure that it's kind of battery included. It's true that that has some compile time implications. So, the first time you compile it, it takes a few minutes, but at least you're ready to experiment, with multiple protocols. And again, it's easier once again to get started without having to understand how you deal with features and so on and so forth. So the bulk of the feature are in place. Now, suppose that on the other hand, you said, okay, hold on a second. I actually want to have a very minimal build because I only need TCP/IP, okay? And I, in fact, want to minimize my footprint. I want to minimize the number of threads. So how do I do that? So in this case, what you would do is that you would run, when building Zeno, or I will show you in how to do it also on a project. But when building Zeno, in this case, you would build disabling the default feature and then picking in explicitly what you want. By the way, recall that the feature system in Rust is additive, okay? And that's very important to keep in mind when we will see some of the examples that I will be showing. Notice that in this case, you will still have support for scouting. I know that this sounds surprising, but as I will see in a few slides, scouting technically is not part of the core Zeno protocol. It's an external module. But again, we will have some slides on discovery coming up, and I'll explain that in a little bit more details. So if you do this, in terms of Zeno protocol, you will be able to communicate only using TCP/IP, but you will still be able to leverage the default scouting, which uses multicast UDP. But you won't be able, by only enable TCP/IP as a feature, to use UDP to proper Zeno communication. And those two things are different. So how do you do that with a cargo dependency? Well, that's how you would add the dependency. So notice that you have to explicitly say that you want to have no default feature, so default feature false, and then you enumerate the specific feature you're interested in, and that's just a comma-separated list. Okay, in this case, I'm only adding TCP/IP. And sometimes, if you're building a minimal version of Zeno, is also because you want to minimize the number of runtime threads. And once again, you noticed and you saw in the example from last week that in Zeno you can use synchronous or asynchronous API. In spite of the API that you're using, under the hood for I/O, we are still using asynchronous Rust. Why? Because that makes it much easier to write I/O code in a scalable, performant manner and in a way that it's easier to reason, okay? So in spite of that, right, in spite of what you're choosing for your API, under the hood, we are still using async, which means that by default, as we were based on async STD will create at least one thread per core, okay? So if you have an 8-core machine, you will have a minimum of 8 cores. That might be too much. And so in the way in which you can control the number of threads used in Zeno is by configuration, by controlling the number of threads used, for instance, for transmission. And this is how you do it. I'll show that in a proper project in a moment. And then when starting your application, you need to make sure that the async std thread count is also defined, so to say how many threads that specific runtime should be using. Okay, so let's see the impact of this in some actual example. So let's open a terminal. Yeah, so I have here an example, by the way, called minimal, that you will find on the webinar repository, that again, as you see here, only includes TCP/IP. It disables the default feature and has a configuration file that sets the number of transport threads to 1. You can play around with this, okay? Now, let me open actually a new window here. Let's say, let's make it blue. So the version of Zeno that I have here is built with the default feature. And if I start, for instance, a subscriber, so the subscriber example, which by now you should be familiar with. So let me start this, and what we will do, I will open the macOS monitor, and we will look at Z. Oh, by the way, I have a bunch of applications already running. I should actually stop them. Let me stop all of this. This will be for later on. Okay, so if we go back here, oh, there is another one still here somewhere. Okay, looks all right now. Okay, let's go back to our macOS monitor, which is here, and we have only our subscriber. So you see, in this case, without any tuning, we have 22 threads. And again, as I said, the consequence is depends also of how async works, right? So that's for an off-the-shelf subscriber. Now, let's keep that one running, and let's look at our minimal project. So that's the attachment. It is annoying when macOS moves windows around, because I had sorted them all. Okay, let's do like this. File, open. Okay, here we go. So let's just build this. I believe it's already built. It's already built. You saw the configuration that is being used. And what we will do now is, for instance, so let me split this in two. Let's start the subscriber. Which, by the way, is called minimal subscriber. And let me show you how the subscriber is done. So essentially, if I pass a configuration, it will read the configuration. Otherwise, if I pass a configuration, it will read the configuration here from the file. Otherwise, it will return the default configuration and will open a session with the default configuration. So what we want to do here, we want to pass the configuration. And notice that here, I didn't provide the environment variable. So if we go again on the macOS monitor, and now we look for the m underscore, we see that I have 12 threads, okay? So let's see what happens now if we actually use for the publisher, okay? Target debug, and this is the minimal publisher in which we pass the config. And also you have a nice README here that will show you how to run the example. So that will, I'm setting the async std environment variable. So if we start this publisher, well, first of all, it's starting to receive data. Good, that's really a good sign. And let's look now at the difference. So you see that the impact of providing the configuration plus setting the proper async std environment variable allow us to go down to 5 threads, which is, which is pretty fine. Okay. So this is the minimal configuration. This is a question that we get all the time. Now you have the answer, you have the configuration, and you know how to do it. So hopefully that that is something that will become will be settled from now on in terms of how do I do that. And again, most of the time you don't care. In some instances, especially if you have 1 zillion Zeno application on the same machine, you really want to make sure that you properly control the number of threads creating by the asynchronous runtime. And this is the way you do, okay? But if you have just a few applications, that really doesn't matter. We have recently an example in some robotics application in which there were, I don't know how many processors on the same processes, Zeno application on the same machine. And that was quite useful in making sure that you limit the number of threads used, because also there are limitations on some system, and you don't want to get into the U limits and all those sort of things. Okay, let's go back to the slides. And let's start looking now at the unstable features that Zeno provide, because some of those are super cool. So liveliness, it's something that I've covered, I think, last year. Super important extension in Zeno, because it introduced the concept of a liveliness token that you can advertise as an application, okay? And this makes it possible, as we supported at the protocol level, to build a very scalable presence and group management, okay? So if you have problem of detecting presence of device, or if you want to do any kind of group management, detecting leave, join, establishing view, that's what you can use. And as it is supported at the protocol level, it's super scalable. Then the next one is attachment. Attachment, as we will see, allow you to literally, like a little bit on an email, provide custom attachment to the data that you're sending. Why would you do that? We'll see in a moment. There are multiple applications. Source info, I am not going to cover it because this is essentially used to provide additional information about the source. There are certain cases in which this is important, one of which is the implementation of the end-to-end reliability, but there are some other cases. Matching listeners, I'm not going to provide any specific example on this webinar, but these are just a kind of listener that allow you to know when your publisher, for instance, is matched by a subscription and vice versa. Okay, so if you have to trigger any behavior in an application when you have a positive match, then there is an interesting one. And then there is the publication locality, which is also quite important, because so far when we were publishing, the assumption is that anybody, forgetting about security for a moment, but anybody that would have, if I was a publisher or a runtime executing a put operation, anybody who had a subscription to a key expression matching the key that I was publishing would receive the data. But here, actually, I can control the scope of the publication. All of a sudden, I can say, well, you know what? This publication is local to this process. It's local to my host. It's local to my network, or it's global. So it's quite powerful, and I think there are quite a few use cases in which you know that some data should remain within the host, for instance, okay? Shouldn't go out, not just because of matter of security, although this is one way of ensuring that data doesn't go out, but also because you don't want to pollute the rest of the world with that kind of information that perhaps doesn't have any relevance for others. And so publication locality allows you to express those kind of constraints. And again, this is an unstable feature. Thus, the natural question is, how do you enable unstable feature in Zeno? Well, that's very straightforward, because you have to do, you can do through build times using the F unstable. So once again, feature are additive. So what this is saying is, please also add the unstable features. That's it. And we will see how we can actually do it from a crate. But let's start with liveliness, and I will go a little bit fast on liveliness because this is really a refresher from something that I covered also last year. But as it is quite important, I want to make sure that everyone is aware of this. By the way, liveliness is heavily used in the ROS2 RMW. It's heavily used also on our ROS2 bridges. And yeah, so it's quite powerful. So I think it's worth understanding what it does. So the basic mechanism that liveliness provides is that of liveliness token. So an application can just declare a token and say, hey, I'm Wolverine, okay, my runtime. And then other applications are able to monitor the liveliness or the availability of this token, okay? So you can do subscription on liveliness token. Notice that this is just a subscriber that you're doing on the liveliness feature of a session. Okay, so Z is our session, .liveliness, .declare subscriber, and before we add, Z.liveliness, .declare token. Okay, that's the API. And so in this case, for instance, I'm interested in having news about X-Men and knowing, when they come around, when they leave, and so on and so forth. Okay, so each time a token that matches xmen.star will be declared on the network, I will be informed. And each time the token will lose liveliness because the application died, because the network got partitioned, or because I disposed the token, then I will be informed that the token is no more there, okay? But there is more, because in Zeno we have query. Wouldn't it be great to be able to query liveliness token? Well, you can do it. You can do it with Zeno. And there is just a little gotcha. So notice that here we were always getting into the liveliness namespace or universe. Okay, z.liveliness declare subscriber. So when you do a query, you have to recall that that's the universe in which liveliness is living. So if you're trying to query for a given token, recall that that lives under the @/liveliness and then / whatever your token of interest is. Okay, so let's see this a little bit in action. So let me start here a subscriber that looks for X-Men. Oh, what is going on? This was precisely what was just running before. My network is fine. Oh, this is quite strange because I was using it. I'm having a problem on my machine. Okay, I know what the problem is. I have something still running here. They're discovering each other and they have, yeah, okay. That was the problem. Okay, good. This is rather odd. What is going on? So I'm having some problem on my machine. I mean, these were precisely the application that I stopped right before. Not sure what's going on. Let me check real quick if I have something else. No, everything looks fine. Yeah, let's do like this. Let's rebuild it because I probably messed up with features. And let's get back to it in a moment. We'll do the demo on this in a moment, okay? So let's start looking at attachment, and then we'll go back to liveliness. So as I was mentioning before, attachment provide a mechanism to associate something, some information with a publication. You can think of it as an attachment that you have on emails. So an attachment is represented as a list of key values. Okay, so you can have actually a series of key values that represent your attachment. And this feature actually was part of the Zeno protocol since the first day. It was there. It was something that we knew it had its use. So, and eventually, user would have asked for it. That's why we had it in the protocol. And we only recently added the user level API to deal with attachment. So the question is, what would you use the attachment for? Well, one very obvious application is end-to-end protection. So I will give you an example with, for instance, computing AutoSAR CRC on some data that we're sending. But suppose that I have some safety applications that, or high integrity application that are crossing boundaries that are not high integrity. So perhaps I trust Zeno, but then I don't trust either the OS or the networking stack. So what I would need to do is to make sure then I can attach to my data some checksums. And for instance, AutoSAR defines algorithm for performing end-to-end protection by means of CRC, but you could use any kind of checksum. That's a way of ensuring integrity. And now the question is, where do you put the checksum? Do you need to pollute your data model with a checksum so that you have to set each time the checksum with your data model? That's not very nice. So in Zeno, you can properly separate the two and just write the data and inject, if needed, right, an attachment. And that attachment, as the example that we will see, could be, for instance, a checksum. So one way of using the attachment is to implement end-to-end protection. The second case is meta information. And here again, if I want to attach meta information to my data, am I going to pollute the data model that then it's exposed to the application programmer? Well, perhaps not, right? So another elegant way of attaching meta information to my data is to use attachment. And one specific use of this meta information can be security. So I can use attachment to carry identities. For instance, if suppose I'm using a group encryption, right, based on a given identity, because there are group keys, then I could, depending on the data that I'm producing, I could encrypt with a group key and provide as meta information, the group ID that members of those group and all the members of those group will have the right key to the code, as an example. But there are multiple usage that you can do of attachment. And again, the limit, as always, is your creativity, because that's just a mechanism that we provide that, again, was always built in the protocol, but never exposed at API level until recently. And again, this is an unstable feature. So let's look at a code example. So in this case, and then we will see the actual code in action. So in this case, oh, by the way, I will have to recompile because I forgot. Well, I told you how to enable unstable feature, but I forgot to enable unstable feature when compiling the example for the liveliness. Anyway, getting back to the code example. In this case, I'm using the CRC crate to generate AutoSAR CRC. So the first few lines of code are just about AutoSAR CRC. I'm computing a CRC, creating a new attachment, and inserting a key value where the key is called CRC and the value happens to be the result of the CRC computation. And then adding an attachment is as simple as doing a put with a key the value and then dot with attachment, and that's it. By the way, the only reason why there is a clone here is that on the code example that I have, the application published in a loop, and so I needed the clone because otherwise the ownership will be gone, okay? But from this specific code example, that could be, it's not necessary. And how do you deal with an attachment on the receiving side? So here you see the subscriber side. So we establish a subscription. Whenever we receive a sample, we take the payload, we compute the checksum, then we look to see if there is a checksum. We extract the checksum, and if the checksum that I received is the same as the checksum that I computed, then the data is valid, and I return true, and I will print, yeah, received valid data. This is the data, and this was the checksum. Otherwise, the data is corrupted. And in this case, we are writing that is corrupted either because the checksum is invalid or perhaps because there wasn't any checksum. Okay. So let's see this one in action. Yeah. So this is the attachment code. So let me run. Let's compile. And again, let's go through the full example real quickly. So we have the publisher here with the proper use, and then we open the session here. I mean, the value never changes. It's just a silly message. Then we create the AutoSAR CRC. That's nice because it's part of the CRC Rust library. By the way, for those of you that are not familiar with AutoSAR, sorry, I gave this for granted. AutoSAR is a standard used in automotive. Most of the cars that are built today are using AutoSAR in some form of manner, especially the AutoSAR Classic. And AutoSAR defines some end-to-end protection libraries which leverage some CRC, and this is one of the CRC implementation that complies with AutoSAR specification. So in this case, we compute the attachment as I showed before, and then in a loop, we're writing this data. And on the receiving side, as shown above, right, we extract the payload, we check to see if there is an attachment, and then depending on whether the checksum is the same as what we compute, we print or not. So what we're going to do now that it has built, let's start the subscriber. And then there is also a publisher that doesn't put any attachment. Okay, so you see this publisher here, it's publishing the same data with the same key, but without putting attachment. So if we start publishing here from the publisher without checksum, right, then the subscriber will simply not validate the data. So if you start publishing from the publisher with a proper checksum, now you see that we receive data from both, okay? So you see the data, let me stop this one so it's less messy. So you see that we received the data and there is the checksum that was computed locally. Okay, so this is just one example of how you can use attachment. Again, it's not the only way of using attachment, it's just to give an idea. But for instance, this is one classical use case that you might have in automotive. Could also be applied in any other domain that requires, again, to ensure end-to-end protection of data. As I go back, by the way, let me change the compilation options. And as I am lazy, I'll do like this. Yeah. So because I recompiled, but I forgot to enable the unstable features, so that wouldn't be very useful. Okay, while this compiles, let's keep going with the slides. Okay, so let's move to discovery. So this is another area of Zeno that poses several questions. So let's try to dissect how discovery works, what are the different elements, and how we call what. Starting with scouting. And as I mentioned before, scouting actually is not part of the Zeno protocol. Scouting is a bootstrapping subprotocol or a bootstrapping module that is used simply to bootstrap Zeno. That's it. Okay. So conceptually, this is the way in which you have to think about scouting. Scouting is able to discover Zeno runtimes and discover the locator at which these Zeno runtimes are available. But you might implement scouting with a database, with a file. However, the default scouting implementation is using UDP multicast to look around for runtimes, right? And eventually, like a little bit the universal plug and play, there is a very small hello message that is just 2 bytes that advertise my presence as hello, anybody around. And as we will see, with that anybody around, I can also say who I'm looking for, because perhaps if I'm a client, I'm looking for peers and routers. I'm not interested in other client, and vice versa. But again, it's not the Zeno protocol. The Zeno protocol starts operating once it has at least one locator to establish a session. And that's where the real Zeno discovery starts, okay? So once again, scouting is a sub-protocol. It is a facility that we have in Zeno, and it's a plugin. And the implementation using multicast is just a default implementation. You could do scouting using LDAP, whatever, okay? DNS, you name it. That said, there are API that allows you to experiment with scouting. So you can actually do scout without having a session, because again, it's not the Zeno protocol, right? But in spite of that, right, depending on which scouting mechanism you're using, suppose by default you will be using multicast, and this is what you have as the only scouting mechanism today implemented in Zeno off the shelf. When you call it Zeno Scout, you can tell, well, in this case, I'm looking for peer and routers, okay? And I'm scouting with default configuration, because the configuration defines perhaps the well-known port on which application will be listening on responding. And what this returns is a receiver, like any other subscriber, that you can, from which you can consume information relatives to runtimes or Zeno peers, Zeno runtimes that have been found. And you will be receiving essentially Zeno information about those runtimes, the locators, and so on and so forth. So you can think of this as a way of browsing your system within the reachability of the scouting mechanism. But once again, scouting is just one mechanism to bootstrap the Zeno protocol, and is not Zeno discovery. Okay, Zeno discovery, as I mentioned, starts afterwards. And Zeno discovery by default works by closure, okay? And what that means is that in Zeno, I could discover by scout a neighbor, okay? But my neighbor's neighbors, maybe I'm not able to discover by scouting. In spite of all of that, okay, through a closure, Zeno is able to reconstruct the exact topology of the network, okay, because of how its proper discovery works. Okay, so first step scouting, who is around, I see someone, and then I start discovery, and I use that anchor point to do a closure and actually discover the topology of the network. Okay, this is what we call gossip discovery. It's the default operating mode, but you can disable it by configuration. Okay, so in order for discovery to start in Zeno, it needs to be able to open at least one session, and from that, it is a closure. Okay, and then we have routing. Once discovery is completed, and again, discovery obviously runs all the time, because if the network topology changes, we need to update our view of the network. Then we can do routing. And there are two ways of doing routings. In Zeno, you can do routing either assuming that your topology is a click, which means everyone is able to directly talk with everyone else, or assuming that, in fact, you are operating over an arbitrary connected graph. Okay. Once again, routing discovers the topology. Discovery discovers the topology, and then routing is used to route on the topology, sometimes having assumptions on the nature of the topology. So by default, peers are configured to use click routing, because usually this is the situation in which you end up in peers, while routers use link state, which is able to support arbitrary graph. Okay. And again, all of this can be changed by configuration. And talking about configuration, I'll open the configuration in a moment. Okay, so all of this is about, again, scouting, who is around, discovery, let me discover the topology, so literally the graph, okay? And then once I know the graph, there is the knowledge that I can use to route. And we have two routing algorithms, which can be applied, right, depending on whether some constraints are applicable, such as I ensure that my system operates under a click. And if I cannot ensure that, then I can use link state, which can work with any arbitrary connected graph. Okay. And now the question is, I know the graph, I know how to route. What am I going to route, right? And that's the next aspect, you could say, of discovery that we don't call discovery, we call intent propagation. Okay. Oops. So intent or interest propagation, sorry. So in Zeno, interest propagation is based on set theory. This is why it's tricky to answer a question and say, yeah, whenever you do a declare, there will be some intent being propagated, because that's not true. And I want to explain with a very simple example why. So conceptually, whenever there is a declare subscriber or declare queryable, those operations may cause the emission of an interest packet, okay? And so suppose that let's assume I'm a client and I'm connected to a router, okay? If an application does a declare subscriber, and that's the first declare subscriber ever since my main was started, you know, it's fair to assume that that intent will be propagated to the router. But after that point, you cannot assume anything else, because perhaps on the rest of the network, depending on the state of Zeno, nothing will be ever propagated, because we don't need to, because there is a set downstream of interest that includes the interest that I just declared. So as everything operates on set theory, right, there isn't always the need to be very verbose and say, yeah, you have to tell everything. No, because they already know that I'm interested in this wider set, and you happen to fit inside this wider set, as an example. So let's go back to my example. Imagine I'm a client connected to a router. Let's visualize this example because that's a simpler. So if I do, that is my main, I open a session with the router, and then I do declare subscriber A/B/***. Okay. So in that case, that declaration will be sent to the router. And then I do a declare subscriber A/B/C/**. In this case, we won't send anything on the network. Why? Well, again, if you look at this in terms of set operation, although those are two different subscribers from an application perspective, in Zeno, in terms of interest, I am not saying anything, that is any different from what I said before. It's just it's a smaller set. So what? Okay, it's something that I can resolve locally, but I've already provided the required information downstream. So this is the intuition and the philosophy that you should keep in mind on how Zeno interest propagation work. Okay, so just to step back, scouting is not Zeno. It's a sub protocol that is used to bootstrap Zeno. Once we have at least one locator, either provided by command line or provided by scouting, then we can do discovery. And that discovery by default is a gossip discovery that does the closure, so that we can reconstruct the actual topological connectivity graph. And that graph can be used for routing. Two algorithms for routing that you can choose. By default, for peers, we use the click, and by default, routers start with link state, but that can be changed by configuration. And then what to send where is decided based on the interest that we have seen being propagated, and interests are propagated, as I've explained, using this kind of set theoretic approach. Okay, so let's keep moving, and let's go now to query and queryable. So as we saw last time, a queryable is an endpoint that answers a query matching a given key expression. And differently from a subscription, the answer to a query is typically a finite stream of key value, although even there you can get very creative, okay? A queryable, it's quite powerful because, again, you can use it to represent either the reading of a data store or to trigger computation. So last week we used it to trigger computation in a pretty simple case because we only had a queryable that was our famous ASCII image generator. Now, how do you declare a queryable? We saw last week there is the declare queryable API call, and then there is another aspect that we didn't cover last week, which is completeness of a query, of a queryable. what does completeness represent? Well, completeness is a way of telling Zeno, if you guarantee that for the key set for which you are declaring you to be a queryable, then you are complete in the sense that if such a key belonging to this set exists in your application, you have it. Okay? I'm not saying that you have the latest value, because there is eventual consistency. Then, we can, if it is storages, we have alignment. But what I'm saying is that if it exists, you have it. Okay? So this is really what completeness means. And that is not actually always the case. Okay? And one way of visualizing completeness, if you think about sets once again, a complete set is a set that is compact. Okay, it doesn't have any holes. Okay, a non-complete set, think of it like Swiss cheese or Emmental cheese. It has some holes inside, and usually, right, storages happens to be complete. And when you define computation, it's usually safer in terms of semantics to declare them non-complete. Also because that has to do with complete versus non-complete function. And again, we don't have time to get there, but I'll give you an example. Even the division function is not a complete function in its domain, right? Because integer division or division in general is not defined when the denominator is 0. There are certain programming languages that allow you to express partial functions like Scala, but most of the language don't allow you to express partial function in the type system. And the sign that the function is partial sometimes can be captured for languages that provide by using options. But anyway, so the intuition is this, complete versus non-complete. Usually a storage, most of the time, makes sense, but again, double check in your use case to be complete, and computation most of the time are not complete. Now, when you issue a query, you can control the target, and the target decides who among the matching queryable or how many will be addressed, and then the consolidation, which is what happens to the reply. Are they consolidated at all? How are they consolidated? And so in terms of query target, you have 4 query targets: best matching, all complete, and n, or complete n. So best matching is essentially the bigger intersection and closer in routing terms. All triggers all queryable that intersect with the query. All complete ensure that only complete queryable that are superset, so complete with respect to your query, are triggered. And complete n means among all the complete querybles that cover your query, right, only n will be triggered. And this is, again, one way of doing a read quorum. So let's see how this works with an example. Imagine that here I'm doing get Zeta webinar Zeno star, and I'm asking for best matching. Okay, so in this case, it will hit that one. Okay, why? Because it's the one with the biggest intersection. And if I do it from here, probably it will pick that one. Okay, then if I do all, then all the matching storage, or storage queryable will be triggered. So this query will be carried up to all those querybles and triggered. And if I do all complete, on the other hand, then only complete storages with respect to this query will be triggered. Okay. And if I do complete 2, then it will be the 2, and again, the 2 closest to me that perhaps might be those 2, based on the current routing situation. Okay. And then in terms of consolidation, there are really 3 options. Known, which means the querier gets all the reply, and then it's you that sorts them out. Monotonic, which means along any routing path, for samples of the same key, the older timestamp are dropped, so you only receive the latest timestamp. but which means that potentially, if you have multiple routing paths leading to you, and on those routing paths there were queryable that were triggered, and you are receiving the same data, perhaps with the same timestamp, on your receiving side, you will still get two duplicate of the latest value of the given key. And with latest, it ensures that for every single key, you get the latest value. So in this case, even if you have multiple paths, there is one other step of consolidation. So you always get one sample per key, per value, per timestamp, okay? And again, depending on how you use querybles, one or the other of these consolidation mode makes sense. Okay, so before moving to questions, and again, checking the liveliness demo again, let's look at, I wanted to share with you some latest news. So the big news last week was that we have merged the porting to Tokyo pull request. This was a pretty sizable pull request. It was merged, I believe, on the 12th of March. And the good news is that all tests are passing, performance are stable, some gains on latency. And again, this has been debated on the Zeno community for quite some times, because originally the reason for us to adopt async STD is that in the early days, and we were probably some of the very earliest adopter of Rust asynchronous frameworks, in the early days, async STD had better performance, especially for I/O. But in terms of the ecosystem, Tokyo has far more ecosystem, and today that was becoming more and more complicated for us, because all of a sudden the core of Zen was leveraging Tokyo, but then for instance Tokyo async STD, but we would have plugin or some for third-party plugin like protocols, or perhaps database plugin, or even transport plugin like Quick that would be leveraging Tokyo. Obviously, you can run Tokyo runtime on async STD. So the other way around, you can run Tokyo Future on async STD runtimes, but again, that's just not ideal. And so we did another in-depth evaluation of Tokyo. We did a good part of the porting, validated performance. Had to look at 2 or 3 things that were, let's say, not immediately green light, but eventually, with the effort of the team, were green light. We are very happy now to have moved Zeno into Tokyo. As I mentioned before, performance are stable, and we have some gains on latency, a little bit of gains of latency, which is always good, but throughput is stable. So all the tests are passing, but again, it was a massive PR, and V1 is coming up, in not so long time. So please help us testing the main branch, because again, we did all the due diligence necessary, but the more testing we have, the better it is for all of us. Okay, so that is it. And before we move to questions, let me see if I can do, yeah, the completion here has finished. There is something strange. Okay, never mind. I have to figure out what's going on this specific. This is pretty strange, honestly. Yeah, that's good here. Actually, let me just close this. Let's do differently. Yeah, I think there is someone, I know what it is. I'm discovering someone on the network that is using the latest, so yeah. Okay, is someone in the lab just messing up my demo? So never mind, because I'm for the other demo I was using the latest version of Zeno. Here I was using the previous release, and we have done some protocol changes for V1. This is what is creating the issue on my demonstration. Anyway, let's go to questions. So let me stop sharing my screen, and if there are questions, I will start answering them. Okay. Okay, so there is a question how to enable multiple feature and disabling default feature. So that's quite easy because if you recall in the code example that I provided, and you have the project on GitHub, you disable default feature, and then there is one target that says features, and between square bracket, you literally list the name of the feature that you want to enable. So that's how you do it. Okay, so other interesting question about Tokyo and the impact on embedded devices. So in any case, async STD doesn't work on embedded devices. On embedded devices, what you have to use is Embassy. And this is what we target for the no STD version of Zeno. So if you search for no STD in the Zeno source code, you will see that there are already some portion of Zeno that are no STD. That part is growing. There is, let's say, an informal project called Zeno Fento, I believe, or something like that. That is about no STD Zeno running bare metal, and that uses Embassy, which is precisely an asynchronous framework for embedded. So in any case, neither Tokyo nor Async make it on deeply embedded, and or at least what we think about embedded. And for those systems, then Embassy does the job. So yes, the basic idea is that eventually we will have an alternative of Zenopico that will be fully Rust, and that's the famous Zenofento. Don't quote me on the name. We all call it slightly different way, but we really mean Zeno STD running on a microcontroller. So, Frederick, concerning the future, one of the effort that we have done and you will see already some of the signs of that effort in the main. So we have inserted an API tagging model that allow us to tag all API of all language bindings and mark different API as core API that all programming languages should have, API that are specific of a given programming language for ergonomicity and so on and so forth. So we're using this table, and this table will be, I mean, we will release the table, but right now we are using it internally to track essentially to track mechanically the differences that there are between different programming languages. What are the gaps? V1 will fill the gaps across all supported programming languages on the core APIs. And at least it will make clear how the different API map on different programming languages. What are the API that are specific to a programming language, because perhaps they make sense in Rust and not in C, or vice versa. They are necessary in C, but not in Rust, okay, because of how Rust works. And so that information will be publicly available. We've built a tool to do all that mapping. And again, if you look at the source code, you will see the tags already in place. So, yeah, as of today, the Fento, we're really working on it like a fun project, so on available cycle because of how much work there is to do. But anybody interested on contributing, I mean, we're happy to, to get contribution. We have already a version of Zeno, a full publisher working bare metal on a microcontroller. Okay, so that we already have. But from there to get also the subscriber, the queryable, because we want the key primitives will be there at Zenopico, there is still some work to be done. And once again, ideally, we would want to have a subset of Zeno really to be no STD. We are getting there, but again, there is quite a bit of work to do. So as of today, we don't have necessarily a timeline for that. Okay, So we are done with today's webinar. Thank you very much, everyone. Sorry for the glitch on the demonstration. I will investigate what's going on. But yeah, see you next week, because next week we will be talking about Zenoh, which is a data flow programming framework native to Zeno, which we are releasing a new version with quite a few interesting improvements. So thank you, everyone. See you next week. Bye, everyone. Bye-bye.